In this video, we'll begin our discussion of what are called trig identities. An identity is an equation that is always true no matter what value you plug into your variables. You guys have seen the top 8 here, so I won't go through those. This in the box, you are going to be expected to memorize these. I have good news though. The top 8 you've already been working with, so you probably already have those in. I've introduced, I think, that one already. And if you can see that these other two are just forms of that first two, and I'll show you that here in a moment. And then this one is a form of these two. And then those two are forms of that one over here on the left. So looks like we only need to memorize maybe these three, the complicated ones. And I'm going to show you actually on the next page how we really only need to memorize this. And from that one I just circled, I can get the remaining 8. Okay, so let's take a look at that. We'll start with, in a previous video, we talked about why that was true. So I'm not going to spend video time again doing that. So we're going to start there. So let's take a look. Let's fill in a few reminding notes. Forgive me, these won't be on your notes. You'll have them blank. So we won't have that. Okay, so we don't have, for tangent, we have a couple definitions that we can use for tangent. I can use sine over cosine. Sine over cosine, or I could even do 1 over cotangent, right? That's the reciprocal function. Cotangent is either cosine over sine, or we could call that 1 over tangent. Cosecant is 1 over sine theta, and secant is 1 over cosine theta. All right, so just a reminder there, because we're going to use those a lot. Our go-to for a lot of our methods in this will be turning things into sines and cosines, so it is very important that you can do all 4 of those, changing to the sine and cosine. Okay, starting with the Pythagorean identity, which is something we talked about in a previous video. Sine squared plus cosine squared equals 1. And they want us to solve that for cosine squared. So if you notice, if I minus sine from both sides of my equation, then I get cosine squared theta equals 1 minus sine squared. That is always true. What we're going to eventually be doing is we're going to be given something like this, and we're going to want to make it simpler. So we'll replace that with cosine squared. Okay, we could have done the same thing by minusing cosine on both sides, so I could have gotten sine squared theta equals 1 minus cosine. So notice, if you go back and look at that table, this was the first one, and then we had this one, and then that one there. Notice that we have all of them, and it's all based on just that top one. All we had to do is minus sine or minus cosine from both sides. Okay, how we can get those other 8 is we start with the beginning. Notice that they wrote it the other way around, but addition can be flip-flopped. So I'm going to divide everything. I write down the equation, and I divide everything by cosine squared. So cosine squared theta there, divide by cosine squared theta here, and even the 1 on the other side. I have to do it to everything. What this gives me, right, cosine over cosine gives me 1. Sine over cosine gives me tangent. And then on the other side of the equal sign, 1 over cosine, well, that's just secant squared. So this is one of those equations. And then they said solve that equation for tangent. Okay, well, I could do tangent squared theta equals secant squared theta minus 1. So that's another one. They don't tell us to do it, but we're going to go ahead and do it anyway. I could solve, oh, it's already solved for secant, so we have those two. I could come up with one more equation. I guess I could do this. I could do 1 equals secant squared theta minus tangent squared theta. I'm not sure what they put in that box. We could come up with a bunch just by moving things around, adding or subtracting that original equation. Okay, so that gave me that special one that it has secants and tangents. And then the next one, how we can get the remaining, is we take the Pythagorean identity that we have here, and we're going to divide, instead of everything by cosine, now we're going to divide everything by sine squared. So I'm going to divide each part of my equation by sine squared. All right, cosine over sine, that gets me a cotangent. Sine over sine gets me a 1. And then 1 over sine is a cosecant. So that gets me the equations with cotangent and cosecant. I could also solve that for cotangent by minusing 1. So there's another equation. And you can, if you go back and look at that table, you'll see that the table on the left, I think it was on the left, will have these three main ones. This one, this one, and then our original. And then the other ones are manipulations of those. So those are my three. Notice the first one at the top there has sine and cosines. The second one has tangents and secants. And the third one has cotangents and cosecants. So I just, the way I just go from the way we derived here. I start with the cosine squared plus sine squared, and I derive them into those. I don't have those memorized, the other ones. I have to derive it every time. All right, some other identities here that we'll end with. I could solve my equation that's solved for sine above, right here. I could take the square root of both sides. So that would give me, remember when we take square roots of equations, we introduce a plus or minus. And that would be the, oops, I forgot it corrects it like that. It would be 1 minus cosine squared theta. I just took the square root to get rid of the sine squared. And then remember when we take the square root, we have to put a plus or minus. Okay, for cosine, it would be that same thing, except for it's not 1 minus cosine underneath. It'll be 1 minus sine squared. And then tangent, based on the equation up here. Tangent is plus or minus the square root of secant squared theta minus 1. But again, there's no reason to memorize all that when we can get it from this original equation gets me there by dividing by cosine, and then it also gets me there by dividing by sine, and then I just manipulate the equations. There's no reason to use all that brain space to memorize every bit of these. You can get to them by memorizing one.